Welcome back to Precalculus. I'm going to work through that example that we did in class. We didn't make it all the way through, so I'm going to finish it up. And I'm going to start from the beginning. I know it's kind of a tricky one, and take it to the end. So this will take a while, take a number of screens. So hang in there. 9x squared plus 4y squared minus 36x plus 8y equals 31, plus 31 equals 0. Okay, so what we're going to do, sorry about that. What we're going to do is, as I said in class, we're going to group our x terms and our y terms. That's not right. Okay. So our x's go together and our y's go together. And the 31, I'm just going to throw the other side. Then whatever is here must be factored out. You have to factor out what's in front of those squared terms. I'm going to change to a better color. So I'm going to factor out a 9. It has to be factored out. Now this one worked out pretty nice. If this were 35x, or 31x, or 34x, or 33x, be bad. We'd have a fraction that we'd have to eventually half and square. So they're probably going to be pretty nice to you, and they are here. I'm going to leave a little space for completing the square in a moment. And then I need to factor that 4 out of the second 2. And again, I get a nice integer, an even integer even. And negative 31 is still over here. Okay, so what is that perfect number? Well, recall if you half negative 4, you get negative 2. And if you square negative 2, you get 4. If you half 2, you get positive 2, you get positive 1. You square 1, you get 1. Remember, you're always adding something, which makes sense because when you square a number, whether it's positive or negative, it's going to be positive. Now, I didn't really add 4 to here, or 1 here. I added 4 times 9. So I need to add 4 times 9 and 1 times 4. So for the first completing the square, I had a 4 I added, but there were a 9 out front, so it's going to be 9 times 4. In the second set of parentheses, I added a 1, but there's a 4 out front, so it's 4 times 1. So this side is going to be 36, 40, and positive 9. Okay, now as I told you before, the factoring is pretty much going to take care of itself if you write down the half number. That's going to always work. You can check yourself if you like, but that will always work. Don't forget those coefficients. Okay, we get here. This is looking very close to standard form, but not quite standard form. We need to divide both sides. Divide everybody by 9. This guy's fine with it, because it's just going to become x minus 2 quantity squared over 1. This one not so happy. This one's just 1, which we need. What happens here, I went over this in class with you, but to multiply by 4/9 is the same thing as dividing by the reciprocal. We've learned that in the opposite before, that if you divide by 9/4, it's the same thing as multiplying by 4/9. So therefore, if you multiply by 4/9, it's the same thing as dividing by 9/4. So that means I can move that 4 into the denominator of the denominator. Another way that I mentioned you could think that through if you prefer is you say I can't have a 4 here, so I'm going to multiply the top by 1/4 and the bottom by 1/4. The top, 1/4 times 1 is 1, so we just have a 1 out front there, and the bottom becomes 9/4. So however you do it, that's how you get your standard form right there. Okay, next thing will be getting our sketching, getting the vertex, focus, co-vertices, eccentricity sketch. So I'm going to go to the next page for that. Okay, so our equation, let me summarize, was x minus 2 quantity squared over 1 plus y minus 1 quantity squared over 9/4. equals 1. So our vertex, not vertex, I'm in the parabola world here, our center, we know immediately, is what makes this first term 0, 2. Remember, if it's a minus, that means the sign must have been positive because the equation has a minus. And the next one is 1. So 2 1's our center. Think for a second, is this horizontal or vertical? It is vertical because the number under the y is larger. So I'm going to make a note of that. And the larger number is our a squared. So a looks like it's going to be messy, but it's actually a nice 3/2, which is 1.5. B squared is the other denominator, which is 1, therefore b is a nice 1. We know the relationship between these is a Pythagorean relationship where a is the biggest, so a squared must go by itself. A squared we already know is 9/4. B squared we already know is 1. That difference will make 5/4 equals c squared, or c is the square root of 5. Square root of 5 is square root of 5. Square root of 4 is 2. Okay, I'm not going to be able to fit all this on here. I guess I'll go ahead and, I'm going to make a sketch of this. I don't necessarily recommend you to do this because you have more space on your paper. Maybe I'll, yeah, I'm going to make a sketch. No, I'll go to the next page. I'll try that. Okay, yeah, let's do this on a new page. So we have all of our components. We're ready to start our graph. I can see the center is at 2, 1. It's going to be vertical. My a is like 1.5, so it's not going to be a huge ellipse. If we go over 2, 1, 2, up 1, put a dot. Oh, that's not 2, is it? That's our center. And I'm going to put a C there, and I'm going to label it 2, 1. I think I like doing that for the center because it helps me visualize it a little bit better. I need to go for my vertices, up and down A. A is 1.5, so up 1, 2, so 1, 2, 3. So I'm going to be at 2.5 there. If I go down 1.5, I'll be here. So my vertices, I'm going to label nicely off to the side. They both have x coordinates of 2, but they go up 1.5, so it'll be 2.5, and then down 1.5, so negative 0.5. If you take the difference of those, how far apart are these vertices? Should note they're 3 apart, which is good because that's 2a. Okay, I'm on my covertices. I think I'm going to do a covert abbreviation. That's going to be fine if you want to do that. B is 1. That's going to be really easy. So this is, you always need to label at least a point on some of each axis. So go right 1 and left 1. Those are my covertices, and over here the CV abbreviation is adequate. So if I went, the y coordinate is going to be 1 in each of them, and my x coordinate is going to be 3 and 1. Difference between those is 2, which is 2b. Let's do our best to make our sketch. I'll make this in a different color, just because I can. Ooh, that is pretty good. Pretty good, okay. Foci is next. Foci are going to have the same, they're going to be up and down, so you have the same x coordinate as the center and the vertices. They go up and down square root of 5 over 2. Let me figure out what that is. One moment. Put it in my calculator here. Square root of 5 divided by 2 is about 1.1. make a little note over here. Square root of 5 over 2 is about 1.1. So I'm going to end up with a dot just over 2 there. That's a focus. And then 1 just below the x-axis. Can't get it to really draw right. That's a focus. You will probably surely do better with your pencil. I need to have a little more space here. That would be, so the center was at 2, 1. So it's 2, 1 plus square root of 5 over 2. And 2, 1 minus the square root of 5 over 2. So those would be the exact coordinates. We could write down an approximation if we want, but that's good enough. Finally, the eccentricity we know is C over A. I'll give you that formula on test. I don't know if I'll ask for it, honestly, because if I give you the formula, there's not much to it, which would be the square root of 5 over 2 all over 1.5, but let's not mix those, so we'll say over 3/2. We'll simplify this a little bit. To divide fractions is the same thing as multiplying, so it would be times 2/3. 2's cancel, so the eccentricity is the square root of 5 over 3, which that is approximately 0.745. It's a good sign. It needs to be less than 1, so that's good. I'd probably take the radical one, be fine. Okay, that's it. Hope that helped out.
Made with Doodlecast Pro.